Hello everyone. Some problems do not ask for effort, they ask for perspective. Take this question. This question was asked in JEE Main 2024. And at first glance, this is familiar polynomial. A polynomial with 4 roots, and we have to evaluate one expression on these values of the roots. So naturally, we begin with where tradition tells us to begin. And the tradition tells to apply the rational root theorem if we know those technique to apply and find out the actual roots of this equation and plug these values of roots to find the expression values. But here is a quiet truth behind this theorem, that the rational root theorem doesn't give you the solutions immediately. It gives you a list of possibilities of solutions, a space where you are allowed to guess carefully, logically, and hopefully. Sometimes guesses fall into space, and that moment will be the luckiest moment. We can identify what are the roots and plug it, and the answer will come immediately. But sometimes they don't. And when they don't work, the method stops. And not because it is a weak method, I must tell, but because mathematics is so honest, it knows its limits. So instead of forcing real roots to appear by applying the rational root theorem or guessing the roots, we change the lens. We step into the complex number system. And in this system, believe me, there's no guessing, no trial and error, only structure and symmetry. What first appears abstract in this complex number system space often becomes the most direct path forward. So in this video, we will solve this same question in two different ways. One is bounded by the real numbers. We apply the rational root theorem, and if the students doesn't know, then you will learn what is the rational root theorem profoundness. And the other one is entirely free from the real number. We will actually solve this question by using the complex number. And we also see that in what context the rational root theorem or the real number domain will not work there. And we will learn more. Because I believe that mathematics isn't just about finding the answer. It's about knowing when we have to change the method sometimes. Let's begin. So first we do this question by rational root theorem. So for one who doesn't know, rational root theorem is a theorem which provides you the list of the possible rational roots of any polynomial equation. So the theorem states in this way: Px is any polynomial a n x to the power n up to a naught is equal to 0. This is a polynomial equation. And if Px has a rational root, then it is in the form of plus or minus p by q. What is p and what is q is this one. P is a factor of a naught and q is a factor of a n. So in this way, we will find out with the positive and negative sign all the possibilities of potential rational roots of any equation. And if the rational roots happens to be for that polynomial equation, then it will come out from those lists only. So let's apply this theorem to solve this question. And luckily, this equation what we have right now, that is 4x to the power 4 plus 8x cubed minus 17x square minus 12x plus 9 is equal to 0, has all the roots rational. So it's an opportunity to understand that how we'll apply the rational root theorem. So x1, x2, x3, x4 are all the roots, and it doesn't actually matter which one will be x1, which will be x2, because this expression what we are looking for is symmetrical. So whatever you take for what, it doesn't matter. Just you have to evaluate this thing. So we apply this rational root theorem. So we identify that here we have the a0 value as 9, and which has 3 factors: 1, 3, and 9. And similarly, the an, the leading coefficient, is 4, and it has also 3 factors: 1, 2, and 4. So the claim is that our roots can be the ratio of these possible factors, all the possible cases with plus and minus sign. So we may have the 1 plus and 1 minus because we are taking this as P and this as Q and making the all possible combinations with positive and negative sign. So the first guess we can make either plus 1 or minus 1. The second guess we can make plus or minus 1 by 2, then plus or minus 1 by 4. Similarly, plus or minus 3, plus or minus 3 by 2, and plus or minus 3 by 4. And finally, plus or minus 9 by 9 actually. Then plus or minus 9 by 2, and finally plus or minus 9 by 4. So these are the possible rational roots if they want to be. If the equation has no rational roots, none of them will satisfy this equation. If the equation has rational roots, we can find that one of them will satisfy. And of course, if 1 or 2 we can find, the other we can use the sum of roots by the coefficients relation, and we can find the others also. So let's try the first one. So 1, if you substitute in this polynomial, so let's call it the polynomial x, px, and we want to substitute 1. So p1 is not equal to 0. We can easily guess or see that after calculation. But let's calculate at minus 1. At minus 1, this will give you 4 minus 8 minus 4 plus 9. That will give you 0. So that satisfies. That means x minus 1 is one of the factor. So we want to construct. So x minus 1 is one of the factor. The other factors we can also find. Since we are learning the rational root theorem, we can keep guessing. So plus 1 by 2 will not work perhaps. So let's see it is working or not. So once you find on 1/2, that is going to be 4 to the power 1 by 16, 4 into 1 by 16 rather, plus 8 into 1 by 8, minus 17 by 4, and minus 12 by 2, and plus 9. So that will give you 1 by 4, 1, minus 17 by 4, minus 6 plus 9. And that is going to be, I think, correct. It will work. So that is going to be 0. If you simplify, you'll get that. So p half is one of the solution. Means p half is 0. So half is one of the solutions. So one factor now is 2x minus 1. Now we go for plus 1 by 4 and so on. But I'm giving you the quick because I have checked of that. So p of minus 3 will work. And p of plus 3 by 2 will also work. So in this way we get here x plus 3. Here it should be x plus 1 rather. Minus 1 was working. And again 2x minus 3. So these are the all possible factors. You can also check it. Sum of roots and the product of roots. So sum of roots, we can find it by using minus 1, plus 1 by 2, minus 3, and plus 3 by 2. And we can add it, it must be minus 8 by 4. So in this way also we can find all the roots, and after that we will substitute these values at the place of x1, x2, x3 and x4. So our expression, let's say it's expression 4 plus x1 square, 4 plus x2 square, 4 plus x3 square, and 4 plus x4 square. We substitute all those values one by one. So first we substitute minus 1, so it will be 4 plus 1, then 4 plus 1 by 4, then 4 plus 3 square, that is 9, and finally 4 plus 9 by 4. And we simplify and calculate. What is that? 5 into 17 by 4, 13, and 25. The giant one, but it is equal to 125 by 16m, and they're asking for that is 125 by 16m, and from there we can simplify it. 16 cancel, and we get the value of m. So this is one of the way to find it out. But the problem happens when we don't have this real or the rational solutions for this. Suppose in this particular situation it worked, but suppose I make these changes, 4x to the power 4, and let's say any random numbers, plus 8x cubed, minus 19x square, plus 17x, plus root 3, suppose I gave you here. Then how do we find it out? It will be difficult because we don't know, because the root 3 is there, and so we cannot take a naught by a to guess the rational roots. It means it has no rational roots. Then how do we find this kind of expression? So first I solve this question by using the complex number, and then you will understand that this can be extended to any version of this kind of questions. So the question was originally, again, I'm just copying and solving it by complex numbers concept. You notice one thing, that x1, x2, x3, x4 are the roots of this. So this is another way we are solving. So we have one thing is clear, that x1, x2, x3 and x4 are roots of px is equal to 0. And you know what I mean px? I'm assuming this equation, this left hand side expression is px. So our px, let me write it, is 4x to the power 4 plus 8x cubed minus 17x square minus 12x plus 9 is equal to 9 actually. So if these are the roots of this, we can also write px in this way. 4th leading coefficient is 4. I can write this polynomial expression in the form of the factors of all the roots. Like I can write 4 times x minus x1, x minus x2, x minus x3, and x minus x4. Let's call it the equation number 1 or expression number 1, whatever you like. Now notice this thing. The expression what we have given is 4 plus x1 square, then 4 plus x2 square, 4 plus x3 square, and 4 plus x4 square. Now notice one thing. I can write x1 square plus 4 as x1 minus 2 iota, x1 plus 2 iota, isn't it? Because a minus b, a plus b will give you x1 square, and minus 2 iota square will give you 4 iota square with a minus sign, so we make it positive. Similarly, I can write x2 square plus 4 as x2 minus 2 iota, x2 plus 2 iota, and x3 square plus 4 is nothing but x3 minus 2 iota, x3 plus 2 iota. And finally, x4 square plus 4 is x4 minus 2 iota into x4 plus 2 iota. And we have to find out the product of these 4 only. So let's try to find out product in a different way. Don't you notice that if this multiply them together, if we multiply, the left hand side will become the exact expression what we are looking for. And the right hand side, I am multiplying in a different way. Either you multiply them horizontally and stack them one after other. You multiply these two and again stack this over this two product before that and so on. You stack this horizontally, or you can also do this multiplication first. This 4 multiplications, and then you do the second 4. So this thing I'm writing the product of these 4 as product 1 and this product 2. What is product 1? You can notice the product 1 is nothing but the x minus 2y, x1 minus 2y, x2 minus 2y, x3 minus 2y, and x4 minus 2y. So notice the product 1 in this context. You notice equation number or expression number 1. Try to relate these two together. How do we relate it? Can you see that the P1 I can write as 1/4 of P at 2i? How do you know that? It's not difficult. X minus xi, x minus x1, x minus x2, x minus x3, and x minus x4. So if we change the order of the values in the bracket, it can be x1 minus x, and since you are changing simultaneously the other bracket, it will not affected by the sign, because this will give you the sign compensation. If you take the minus sign out of here, the other minus sign you are taking from here will be compensated by the product of the two negative. Similarly here, you get x3 minus x1 and x4 minus x. x3 minus x and x4 minus x. So this is P1 is nothing but 1/4 times of P of 2i. And similarly, you notice the P2. The P2 value, we are evaluating the P again at minus of 2i, isn't it? So the P2 is 1/4 of P at minus 2i. And the product, that is expression E, is nothing but P1 times P2. And so it will give you 1/16 of P of 2i and P of minus of 2i. And this is nothing but you are evaluating the polynomial, this long polynomial at 2i only. And there are many values like I to the power 4 will become 1 and so on. The only matters how do we manipulate smartly, because P of 2i, whatever it gives, the minus 2i will give the conjugate of it. And when you get the two conjugates product, it will be easy to find it out. So I'm not evaluating. I know that you can evaluate it easily. Now, why this method works in a very elegant way, and it works for every such situation, because suppose I give you this kind of situation in which I have a px polynomial as, let's say, x to the power 6 plus 5x square plus root 3x, 5, then 4, then minus 3x3, and then let's say again root 3, I'm writing x square plus x plus 1, 1, 2. And this is this equation here. And they're asking the product of all these values running from I to 6, I is equal to 1 to 6, and I'm asking xi square plus 1. And they're asking the product of all these roots. Xi, x1, x2, x3, x4, x5, and x6 are the solutions of this polynomial. Now, how do we solve this one? Because we know that there are many irrational numbers are involved here. Even if you find the factors 1, 1, 2, it will become many of the factors, and they are satisfying or not, we don't know, because they are rational, irrational or not. So in this way, these questions become complicated by using the real number system, or this real number domain, I can say. Means rational root theorem you cannot apply or simply guess it. So, but this method, what you learned right now in this complex number space, it is convenient and it can be applied everywhere. How do we know that? Because now you know that this is nothing but, if you simplify this, is nothing but the product I goes from 1 to 6 is nothing but xi minus iota. By the way, let's say k here, because I don't want to confuse it with the I 2 times. So one is iota, one is index, so it will be convenient if I take this k. Okay, so xk minus I, and then xk plus I. And since we are multiplying these two brackets, we can multiply vertically also, like xk means x1 minus I and so on, and you know what to do. You know this is nothing but there's no leading coefficient here, so you don't have to worry. We can simply see that the p of I into p of minus I. And in this way, we can evaluate this polynomial at this iota and minus iota, and it will be easy to find the product. So this is the way we can apply the complex number in this kind of situation. And in JEE Main, they have asked in 2024, and if we were lucky enough to get all the roots, maybe their intention was there to like make every student find all the roots, but in sometimes what the way they are actually raising the level of the questions every year, maybe near future they will also make our life in trouble by not giving the exact real roots, but simply expect from us to apply the complex number, because this is not so difficult to apply. Maybe they will give the expression like this, not plus 2i or minus 2i we have to evaluate. Maybe this xki square plus 1, so that we can easily identify that iota can be substituted or minus iota can be substituted. So this was all for today. But anyway, at the last, one thing more. This can be, many students also tried in my class by using this sum of roots, product of roots, by the Vitas theorem, what we call, by relating the roots, sum of roots and product of roots with the coefficients of the polynomial. So that is a very quite lengthy process to find out exact values of the x1, x2, x3, x3 and x4. So rational root theorem is a very underestimated theorem. You know how to apply it now, because this will give you the list of all the possibilities. If you don't know, then we actually don't know what to substitute, what will be the guess. But now at least you know what are the possible guesses. In this way, rational root theorem is also profound, and also this complex number way. So that's all for today's video. See you in the next video with such other this kind of questions. Stay math active.